Thank you very much. Very quickly, okay. So, of course, Kubernetes is not the easiest word in the world to pronounce. Funny story, years ago, it might not be funny. Years ago, when I was first getting into Kubernetes, my wife would hear me talking about it on Zoom calls or things like that, or she'd hear me just referring to it. And it wasn't quite an established word in our family at that time. And she famously, within our family, used to call it Kumbernauts. Are you working on that Kumbernauts thing again? I'm like, Kubernetes, never mind. Can I get a super quick show of hands? Who does anything already with WebAssembly? Uh-oh. Okay, so this is a good audience for me. So this session was originally put in as a workshop, but we don't have tables and things, so it's more of a live demo now, but I'm going to show you a link to a GitHub repo where you can run all the commands and things later on in your own time. So come on, let's crack on. This is me. I've been involved with Docker and containers and Kubernetes and now WebAssembly for a little while. Just very quickly, okay, I want to set the scene a little bit for WebAssembly. Years ago, when I first got my hands on VMware, virtual machines, I was young, and I didn't really understand a great deal about technology, but I love technology. And that first experience with virtual machines or VMware literally blew my mind. This idea of running multiple computers on a computer, I was like, head explosion. And I could see almost straight away this was going to be a huge thing. So I decided to dive in at the deep end, and it was really positive for my career. Then a few years later, Docker came along, and it was really early. I did a little bit with Docker 0.7, but 0.9 was when I first got into it. But I still remember that first time I spun up a Linux container and figured out how it was different to a virtual machine. I had that kind of head explosion moment again, and I dove straight in and thought, this is going to change the world, and it did, just like VMware did. Similar experience with Kubernetes, though I don't feel like Kubernetes changed the world quite the way that virtual machines and Docker did. Fast forward to kind of the present, and I was starting to hear this Wasm or WebAssembly, and I'm like, you know, you hear it enough times, and at some point you're like, right, I'm going to have to just at least wrap my head around what the concepts are so I don't embarrass myself in a conversation with somebody. Because the problem is, so I write books, okay, and as soon as you write a book, people suddenly think you're amazingly clever and you know everything. And that puts like loads of pressure on you. So people would come up to me at events, and I was kind of scared somebody would come up with me. So what do you think about this WebAssembly stuff? And I'd be like, I don't know. Anyway, so I tried to figure out WebAssembly, and no joke, this isn't like, it could turn out to be maybe nothing, but it was immediate. It was like with VMware and Docker. I was like, head explosion. This is going to change the world. I threw my Speedos on, dove straight into the deep end, and here we are today. Anyway, you'll hear around at events like this and other cloud-native events, people talking about 3 waves of cloud computing. So the first wave was virtual machines. They kind of kicked off the whole cloud. We did everything in virtual machines. Along came containers. Smaller, faster, more portable kind of just because they're smaller, really. But they could do things and go places and run places that virtual machines couldn't, and they were just way more efficient. So they drove, or they powered, I guess, a kind of a second wave in cloud computing. Well, there's a third wave coming, so we're all out there, we've got our bodyboards or surfboards or whatever, and I felt like about a year ago, I don't know if you've done bodyboarding or surfing at all, but you're kind of a little bit out in the ocean, and you see these ripples, and you're like, that one's going to be a wave, and sometimes it is, and sometimes it's not. But I felt like the wave was quite far away a year ago, whereas now I'm like, the wave is here, I'm getting on the board, and I'm giving it a bit of this, and it looks like it's going to be a big wave. Anyway, that's basically setting the scene. Now, I do want a shameless plug the last session of the day today, right? 4:05, downstairs in breakout room 2. If you're watching this on YouTube or wherever later on, there'll be a link to the session. But we're going to have a pretty, I'm hoping, honest and open conversation about the future of WebAssembly, its strengths, its weaknesses, what its good use cases are and what it's not good for, but also this coming together of WebAssembly and containers. Is it a thing? And if it is a thing, is it a good thing? Is it not? Anyway, later on. Right. This is the agenda. This is what we're going to do. Now, I am encouraging you just to watch. You can follow along if you want, but I've got to keep the pace up a little bit. We're going to write a super simple Rust web application. Now, I am as far away from a Rust developer as it is possible to get. I couldn't write Rust code if my life depended on it, but we're going to use a tool that makes it super simple, the way Docker makes things simple, okay? So we're going to write a simple Rust web app. We are going to compile that to a WebAssembly binary. We'll talk a little bit about what a WebAssembly binary is later, and we'll see it. Then we're going to test it and just make sure that it works. And it's going to be so simple, you're either going to be like, gee, why did I bother coming to this session to see that? Or you're going to be like, wow, that's actually the cool part. The fact that it can be so simple is what's good about it. Then, these are the commands that we're going to use, by the way. We're going to use a WebAssembly framework from the folks at Fermion called Spin. Other frameworks and other WebAssembly runtimes and tools do exist, but this one's just going to make it super simple for us. We're going to take the WebAssembly artifact after this, though, and then we're going to use Docker tools that we already know to containerize this into an OCI image or a Docker image, yeah? Then we're going to use Docker run, and we're going to run that compiled WebAssembly app inside of a Docker container. Then we're going to push it to Docker Hub. Again, other registries do exist. Docker Hub's just super simple. Basically, any OCI registry or any registry that supports OCI artifacts will be cool. So we're going to have built and compiled this app. Then we build and package it into a Docker container. Then we're going to build a Kubernetes cluster, multi-node cluster, all right? All doable on your laptop. It's going to have a load balancer exposed onto my machine here on port 8081. And we're going to use this port a little bit later to access the WebAssembly app when we've got it running on a Kubernetes cluster. So we'll spin up a 3-node Kubernetes cluster, the node on the far end, control plane node, right, and then 2 workers. The important thing is we're going to have some software on there that will enable us to run these WebAssembly workloads. And it's all super simple containerd stuff. Is there anybody who doesn't know the fundamentals of Kubernetes? And it's totally OK if you don't. OK, right. Right. So Kubernetes is this super high-level orchestrator. I got some slides on in a minute. But Kubernetes sits like right at the top there, and it's kind of accepting work from us, and it's saying, OK, node 1, go and run it, please, or node 2, go and run this task. Kubernetes actually can't run containers or do low-level stuff like that. Uses other tools for that. And probably the most popular tool for Kubernetes using to run containers is a tool called Containerd. So most Kubernetes clusters that you spin up out in the wild will have this Containerd software on it already. Our build is going to be a little bit special. We're going to have a WebAssembly runtime on there. Lots of jargon right now. We're going to see it, so don't stress if this feels like a lot. 3-node cluster with enough software on there to run a WebAssembly app. We're going to label one of the nodes to help Kubernetes schedule our WebAssembly app. And we're going to deploy something called a RuntimeClass. So much jargon, I'm really sorry. Very quick story, right? When this was originally going to be a workshop, we budgeted 45 minutes. And I ran through it the other day, and I finished in 17 minutes. So this might seem complex, but when we get to do it, it's really not. So simple. Anyway, we're going to deploy a RuntimeClass to our Kubernetes cluster. We'll deploy an application to it that references the RuntimeClass, and that's going to make sure our application gets scheduled on the right node. And then we've got a bunch of networking stuff and ingresses and things just to make a web client or a browser on my laptop on that port 8081 be able to access our application. That is the plan. A few prerequisites, OK? You will need an up-to-date version of Docker Desktop. There's 6 prerequisites, so if you're going to take a photo, wait until number 6 is up. This is the GitHub repo at the bottom, by the way. If you want to follow along, or if you want to do this exercise later at home or in the hotel or whatever. The reason you're going to need a relatively new version of Docker Desktop is it's got some functionality or support built in for WebAssembly. Right now, these are kind of experimental features that I'm going to show you how to enable. In the future, if you're watching it on the video, they may be turned on by default. Okay, you don't need a Docker Hub account. Other registries exist as long as you have some way of pushing the software to a registry, because the Kubernetes cluster is going to need to be able to pull it from a registry. You will need Rust installed. Other languages are supported: Python, C, Go, bunch of languages. We're just going to be showing Rust. The Fermion spin application, you will need kubectl. That is the Kubernetes command line utility. It seems really complex, but it's not. And K3D to build our Kubernetes cluster. If you want to take a photo, now is the time. Okay? Right. Just wait. I'll tell you what, I'll take a little drink of water while people focus their cameras. Three, two, one, it's gone. Right, okay. It's time to get to the demos now. So we are now about to build and compile a simple application as a WebAssembly binary. Now then, can we see? I think we can see. So the first thing we're going to do is use the Fermion spin application, which I've got installed. Oh, no. I want to show you the prerequisites, don't I? So in Docker Desktop, at the moment, if you go into Settings and Features in Development, you want Use Containerd for pulling and storing images enabled, and this checkbox down here, Enable Wasm. Okay? Like I say, in the future, these may be turned on by default. Right now, you need those 2 checkboxes clicked, and then hit the Apply and Restart button. We can see I've got Spin installed on my machine. Now then, you're also going to need, if you've got Rust installed, okay, you will need to add the Wasm32 WASI target. I've already got it installed on my machine. Here it is, this one here. Now, what this is going to do, this is interesting, okay, and it's at the core of WebAssembly. When you come to compile an application, normally you will say, right, I want to compile this application for whatever, ARM and Linux, or Linux on ARM, yeah? Or Linux on AMD 64, something like that. Well, WebAssembly is its own instruction set architecture, or binary instruction set, meaning instead of compiling to Linux on ARM, we can now compile to Wasm, and that application will run anywhere or on any system or host that has a WebAssembly runtime. So very much delivering on the promise of build once, run anywhere, making it a lot more portable than containers. Okay? So I've got that installed. Any other prerequisites? No, I don't think so. Okay, so apologies if I keep doing this. I just want everybody to be able to see the text as much towards the top as possible. So if I go spin new, this is going to allow me to build a new application in any of the languages that are on the screen right now. Like I said, I have no clue how to code Rust, but I'm brave, so I'm going to deploy an HTTP Rust application. So if I hit return, I'm going to call it DockerCon, of course. Everybody enjoying DockerCon, by the way? Yeah? Oh, that's what I'm talking about. OK, cool. So I call it DockerCon, don't care about a description. And I want this web application to respond on, I'm going to say, yo, because I'm stuck in the 90s or the 80s, maybe. But that will give me a new directory called DockerCon. And if I look at the contents of that directory, I've basically got 3 files. So lib.rs is the Rust application. So if I go vim and I edit this, I'm going to do the usual and say, instead of hello Fermion if you are listening, by the way, or watching, but we're going to go, I was going to say because I'm cool, but it's so uncool, we're going to go yo DockerCon with a capital C in the middle there as well, and a few of those. Whoops, oh, don't want to do that. So save my changes. But basically, that is the application. Simple web server. The spin.toml file here is a little bit important. This tells Spin, and I'll tell you what Spin is again in a second, but this tells Spin how to run the WebAssembly application and how to build it. So Spin is a WebAssembly framework that comes with a WebAssembly runtime and a bunch of tools that make it easy to build and deploy WebAssembly applications. For example, this line kind of close to the bottom here, when we do a Spin build to build the application into a WebAssembly binary, behind the scenes it's going to run this kind of scary Rust command, cargo being the tool in the Rust tool chain that lets you compile Rust applications. So instead of going cargo build -- target blah, 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 I'm just going to go Spin build. So thank you, Spin, for making that easier. But it also tells the Spin runtime how to run the application. So this is where it's going to build our WebAssembly binary. So yeah, basically, 3 files. I don't care about cargo.toml at the moment, so just 2 files that we're interested in. If I now go Spin build, and hopefully over the conference Wi-Fi it doesn't take too long, this is going to build or compile that application as a WebAssembly binary. Fingers crossed it doesn't take too long. Prayers to the demo gods. So that's not bad. Okay, hang on. Now, if I do another tree, loads more files, okay? But not to be put off or be scared. This one here, docker.wasm, this is our compiled WebAssembly binary. So no joke, right? Spin new, give it a name, give it a path, spin build. I'm like feeling pretty clever right now. I have compiled a Rust application. If you don't know Rust, I'm reliably informed it is a rock-hard language to learn and work with. And WebAssembly is super new, and I am not the cleverest person out there by a stretch, but I have just compiled a WebAssembly application, and I feel pretty good about it. Super. So any file that is a .wasm file is a WebAssembly application. Now then, OK, so we've got the file, but does it actually work? Well, just to test, all we do is spin up, and that brings up our application, and it is listening on localhost here on 30,000. So if I jump over to a browser, cheeky new tab. Ooh, that's tiny. Let's make this humongous. Let's go as big as we can. Huh, 500%. That's the biggest that will. Who knew? You can't go bigger than 500%, but there is our application. It's actually working. But that's not what we're here for. We are here to be able to run it in Docker and to run it in Kubernetes as well. So where are we at? Let me just kill the application here. Do we have anything on the slides? Because I want to try kind of my heart. Whoops. Oh, yeah, we're there. OK, so we've built and compiled the Wasm application. Now it's time to package it as an OCI image, run it with Docker, and push it to Docker Hub. So Docker's Docker, right? Even with WebAssembly. And in order to build something, Docker really likes a Dockerfile. But I don't have one yet, so I'm just going to create a brand new Dockerfile in the root directory of the application here. And I am going to jump over to my GitHub repository that has a Dockerfile in it. Now, look, we're here at DockerCon, right? And if you go to a bunch of the sessions, you are going to see some humongous Docker files that like make your eyes want to bleed. Well, we're bleeding edge stuff here, WebAssembly and everything, right? So this is going to be a complex Docker file, I'm sure. Oh my goodness. Like, I reckon, oh, I've gone too big there. Probably the easiest and simplest Docker file you're going to see here today at DockerCon. So I'm going to copy this text into the file in a second. But basically, whoa, the time. We are saying instead of building from a Linux base image like we normally would, this is a WebAssembly app. It doesn't need any of that. We're going to build from the empty scratch image. And then all we're doing is we're copying. Now, this is important. We're copying in the built WebAssembly binary here. And we're copying it into the root folder of the container. Okay, that's going to be important because we're going to have to edit the spin.toml in a second. But we're also copying in spin.toml because that's going to tell the runtime when we come to execute it on Kubernetes exactly how to run this application. So Ooh, I've gone way too big to even have the copy button available. So if I copy that into here, so simple. That's saved. And I do need to change the spin.toml file, because like we've just seen, in the container, we're copying the WebAssembly binary into the root folder of the container. So we do not need any of this long leading path here. So DockerCon.wasm is what it was called. If we save our changes to that, we are ready to do a Docker build. Now, I want the command a bit higher up for you. So if I go, now I'm going to go Docker build X, okay? You don't have to do build X. You can just do Docker build on the most recent versions of Docker Desktop. But I'm going with build X here right now, just in case you're running older versions or anything like that. There's a new flag here that you may not have seen, this platform WASI/Wasm flag. That's going to write some metadata to the image that's going to say architecture is this and operating system is that. And then tools such as Docker Run can then reference this at runtime and help it build the right environment. And then, of course, I'm just tagging the image with however I want to tag it. So I'm going to push it to Docker Hub later. My user ID on Docker Hub is Nigel Poulton, so I've named it like that. So let's build it. And it's already built. And so it should, right? We're basically, all we're doing is we're copying in two files. One of them is a really small WebAssembly binary, and the other was a configuration file. So if I go back to the top, this is going to wrap across the lines, right? But Docker images in, what did I call it? I think I've got spin in it somewhere. So yeah, okay, so I've got some line wrapping, but this is our Docker image here, and half a meg, right? So I don't think I said this at the beginning, or maybe I inferred it, but when containers came along as the second wave of cloud computing, they were smaller, faster, more portable than virtual machines. Well, WebAssembly, smaller, faster, more portable, and more secure than a traditional Linux container. So that's, you know, we've got that as a container image there, 500K. Fabulous. All right, well, now that it's packaged as a Docker image, we can execute it with Docker Run. So we're going to call the container DockerCon, obviously, again, because we're here at DockerCon. The runtime flag here is saying, OK, this is a little bit special. It's not a traditional Linux container. So containerd, when you come to run this, instead of using runc to go and talk to the kernel and build namespaces and fork a process and start the app in there, talk to a different runtime, please, and we're asking it to talk to the spin runtime. We are also specifying here platform WASI/Wasm, but we don't have to. Let me just do this real quick. So if I go docker inspect and just grab the ID of the image here. I just wanted to show you this. Yeah, so when we built the image, we set a couple of, we said that one of the flags, the platform flag, was going to set the architecture and the OS. Docker Run can read this. I don't need to actually specify this on the Docker Run command line, but I'm going to just for completeness. Just make sure I've got the correct Docker Run command here. It is, so we're going to be exposing the application on port 5005 on my laptop here, and we are referencing the correct, of course, like any speaker that is nervous before speaking, as we all are. I've been practicing. So if I just go Docker Run and, oh no, I'll tell you what, I will Docker PS. That is a lot of line wrapping. Oops. I can hear people tell me how to do it easier, but my typing while I'm up on stage is shocking. I think, doesn't matter if you guys can't see this, it's going to be, I can't tell if that is, yeah. That, I reckon that's the one, so if I go Docker, rm this, and please go away as quickly as possible, run that Docker run command again. We've got a container. And if I now go to port 5005, I think it was, localhost 5005, and it's yo. super small again, but let's make it big. So same WebAssembly application, packaged as an OCI image, running as a Docker container. So easy, even I could do it, okay? Brilliant. Progress. We want to actually run it on Kubernetes as well. So, in order to do that, I'm going to make this a little bit bigger so we can all see again. I am going to push it to Docker Hub. Again, regular Docker push command, super small, even if the conference Wi-Fi is shocking, it's going to arrive very quickly. If I go up to Docker Hub now, refresh this page, we should get a new image called spin. Here we go. And there it is. Operating system architecture Wasm. Make this bigger. And about 500 meg. So it's now up on Docker Hub as well. And the point to take here, right, is that I know I'm overstressing this. I'm not a Rust developer. Yeah, I know a little bit about Docker, okay. But these are just our regular commands that we're working with Docker here. There's nothing actually new so far for WebAssembly. Which can be quite a powerful thing when you're in an organization or you're an individual that's invested a lot of time and effort in learning and deploying and you know, having your staff work with these tools. So we are now pushed to Docker Hub, which means we are ready to go and build a Kubernetes cluster. Now, just looking at the time, I'm going to just very quickly rattle through this bit here. We're about, yes. I'm going to build a cluster with K3D, which, don't worry that that's wrapped. I've got a slide to show you the command that's running. I'm going to kick this off because I don't know how long it's going to take over the conference Wi-Fi. So while that goes away, we're going to come back to PowerPoint. This is the command that we're running here. So K3D is a really small distribution of Kubernetes that runs inside of Docker. So easy, if you've got Docker Desktop on your machine, to spin up a multi-node Kubernetes cluster locally, okay? So the command basically says, K3D cluster create, we're going to call it Wasm. That's going to get us a small Kubernetes cluster with a single control plane node. We're telling it which image to build our control plane and worker nodes from. And then we're saying, okay, we want to be able to access our applications inside of this cluster from port 8081 on my laptop. And can I get 2 worker nodes as well, please? So on the right-hand side is a picture of what we're actually going to get. The important thing is that this image here comes with all of the Wasm stuff already bootstrapped into your Kubernetes worker nodes. So we don't actually have to install any WebAssembly stuff into this cluster that we're building here. We're going to inspect it so that you see what's going on behind the scenes. But if you have an existing Kubernetes cluster and you want to add WebAssembly support like runtimes and shims and things to it, I recommend you check out the Wasm project, Wasm, if you have an existing Kubernetes cluster. So now then, right now, this is like moment of truth for me. Has this cluster built over the conference Wi-Fi? I feel like it's a little bit like Schrodinger's cat, right? That's both dead and alive until we observe it, until we collapse the wave function. So I'm about to look and see, I'm about to collapse that wave function, and right now, it's successfully built, it's also failed, and it's still trying to build. So what's actually going to happen? Whoo, boom, it's... Round of applause there for quantum physics, appreciate that. So if I go kubectl get nodes, we should have a 3-node cluster, which we do, a control plane node and 2 worker nodes. Right, next up we're going to go to WebAssembly configuration. So back to the slides really quickly. I said before that Kubernetes is this super high-level orchestrator, and it asks other tools to do the low-level work of building containers, starting and stopping them, right? So there's Kubernetes up in the heavens or wherever, and it's lazy, okay? It's like, I don't want to build containers. Containerd, you do that for me. And Containerd, despite being called Containerd, even it can't start containers, so it says, okay, well, I'll get somebody else to start them for me. This is basic Kubernetes stuff, okay, but it talks to a low-level runtime called runc. It says, runc, please go and do the horrific kernel work of building namespaces and C groups and things like that, and out pops a container. And then runc's done its work, and it wants to take a rest, so fire up a shim, and a shim basically sits in between the running container and keeps container D in on the loop, like, yeah, we're still running, and if container D wants to stop the container or restart it or anything, it can talk to the shim. Fabulous, basic Kubernetes stuff. However, everything on this diagram below container D is opaque to Kubernetes. That means Kubernetes can't see below or doesn't care about what's below. And to be honest, below the shim, even container D really doesn't see that. So this kind of architecture means that we can swap runc out for something totally different. Kubernetes doesn't know or care. Container D almost doesn't know or care as well. So we can put in a Wasm shim. Now, the architecture of a Wasm shim is slightly different to runc, okay? Got a picture of it, right? So a Wasm shim has two main components. It runs this code called runwasi, which is a Rust library that basically interfaces with containerd over on the left there, my right. It's got another piece of software in there, which is the Webassembly runtime. And that's what actually starts the Webassembly host and starts the Webassembly applications and things. Now, runwasi is an official containerd project. So this is all legit stuff. I'm super proud about this, right? I designed that runwasi logo. Shameful plug, but I love it. Because I'm not a developer, I love different ways that I can contribute to the community. And I made a logo. Anyway, it's always runwasi for WebAssembly stuff with containerd. However, the Wasm runtime, there's loads of different ones out there. We're using the spin runtime here, okay? So that's the basic architecture. Now, back to this diagram. Out pops a WebAssembly application. It's basically how it is. So, actually, just going back here, we're going to make sure that we have got WebAssembly runtimes on at least one of our worker nodes. So, I am back at the command line. We've got this 3-node cluster, and I'm going to say, yeah, docker exec, and we're going to go on to, I'm going to call it worker 1. It's agent 1, okay? So, we're going to get a shell on there. And going to put it up at the top. And we're going to, first of all, we need to make sure that containerd is running, okay? So here is containerd, so that's running. We then need to make sure that we've got some WebAssembly shims on this machine. So ls, they generally get installed in the bin directory, and they are always prefixed with the containerd-shim prefix. Okay, so I can see we've got 5 shims on this machine. Runc is the default one for running Linux containers. The other 4 are WebAssembly shims, okay? And the one that we care about is the spin shim. Fabulous. Having it installed in that directory is not quite enough, though. Oh dear, there's a really long path I have to type in this next command, okay? We need to make sure that, we need to make sure that these shims are registered with containerd, or they exist in the containerd configuration file, which normally is in /etc, but on a K3D cluster, it's about 1,000 layers deep in the file system. So it's in var, if I get this right, I'll be so proud, var lib rancher, K3s, it's, ooh, no, agent, agent, etc, containerd, and it's called config.toml. Fabulous. They're at the bottom of the configuration file as well. So we have got 4 WebAssembly runtimes here referenced in the containerd configuration file, and we are interested in this one at the top, the spin one, okay? Fab. Just in the interests of time, okay, I've got another super long command that will dump the active containerd configuration just to make sure that it is loaded. Trust me, it is loaded. So right now, we have got a 3-node Kubernetes cluster. We've got containerd running. We've got a WebAssembly shim, which has a WebAssembly runtime inside of it. We've got a WebAssembly application loaded up on Docker Hub. We're almost ready on our Kubernetes cluster to run this application. However, well, do you know what? We could actually run it right now. This cluster here, every node, including the control plane node, has exactly the same configuration. So all running containerd and all running the spin shim. In the real world, though, you're probably going to have more of a heterogeneous node configuration where some nodes have some Wasm shims on, some nodes have no Wasm shims on, and some nodes have other Wasm shims on. So in that kind of situation, you need to be able to label your Kubernetes nodes so that we can schedule our work to the correct node. Now, we know that Agent 1 has got the Wasm shims on. The others do as well, but we've just been on and we know for sure that this one does. So if we do a kubectl label, don't hurt me here, kubectl label. There we go, okay. Agent 1, and we're going to just add the Wasm equals yes label. Use whatever label you want, it doesn't matter. So we've labeled that node. Now, the final thing that we need is a runtime class. I'm going to make sure we haven't got any here yet. kubectl get. I really wish there was a short name for this. Runtime class. That looks right. OK, no runtime classes yet. So very quickly on the old PowerPoint. We've got 3-node cluster. We know that spin, the WebAssembly shim or runtime, is running on Agent 1. We've labeled that. Now we're adding a runtime class. Now, the runtime class does two things. It selects on nodes with that label. So it is visible. That's kind of a little bit white text on yellow is not great here. It's saying select or send or schedule work to any node with the Wasm equals yes label. But also, when you hand the work over to containerd, tell it to use the spin shim instead of the runc shim. Fabulous. OK. That means we can then deploy an application. We'll see it in a deployment.yaml file in a minute that references this runtime class, and the application will be deployed to the node. 8 minutes left. Uh-oh. I said I was not going to run over time, and I will not run over time. But we are going to go straight back to the command line here. So now that we've got that, I need a runtime class. And oops, it's here. We've got one in the GitHub repo here called rc.yaml. And as we can see, I'm going to paste it in, and this text will be a little bit bigger when I paste it into the runtime, into the file here. So if I go vim rc.yaml, whoops, and paste it in there, basically we can see it's got a name. It's called rc spin. We're going to reference that in a deployment file in a minute. It's going to make sure that the spin shim runs the work, and it's going to send it to any nodes with Wasm equals yes. Fabuloso. So we've got the runtime class created. Next, we need to create our application file. So if I go vim app.yaml and back to GitHub here, we can see we have got an app.yaml file here. I'll walk you through it in just a second. Right, OK. If you don't know too much about Kubernetes, this is going to look horrific. It's not really. We're basically saying, OK, this is our application. It's up on Docker Hub. That's what we call the image. Can I get 3 copies of it on my Kubernetes cluster, please? And when you come to schedule it, Kubernetes, because it's special, it's a Wasm application, schedule it according to the rules in that runtime class we just created. So Agent 1, and make sure that the WebAssembly shim, the spin shim, runs it. We've got some more stuff down here that I'm not going to go into that's just going to make sure that we can then connect to it. So if I save that file and I go, just want to make sure I didn't want to say anything else first. No, I did not. So if we go kubectl apply, this is how we deploy applications to Kubernetes. And we can see that, OK, our deployment was created. The service was created and the ingress was. And if I do a kubectl get deploy, we should see 3 replicas. Ooh. Oh. I didn't apply the runtime class. Somebody's watching. I love it. OK, so I'm just going to kubectl delete. Thank you so much for that, because do you know what? Live on stage, I was never going to troubleshoot that when the clock's flashing at me. So I'm going to delete this first, just in case, just to be cleaner. Kubectl apply. The runtime class. It's falling apart. It's not really. Did I not save it? Louder? Oh, teamwork, love it, brilliant. Okay, let's find that one that deployed the app. Yeah, it is, and that's the run. Right, no, not that one, not that one, not that one, not that one. This one. Right, okay, kubectl get deploy. 3 already up and running. Yeah, take it back. You're giving yourselves a round of applause there. It should be me that's clapping. Okay, so the application is running. What I want to check is if I do a kubectl get pods, and I think if I do an O-wide flag, I should be able to see. It's not easy to see because it's wrapped, but they are all running on agent 1. So the runtime class and the label has done its job. It has sent them to the correct node. So that if I come back to my browser here, let's lose this, and if I go localhost, and it was 8081 on the yo flag, and so that has, if I click refresh, it's done it. So it was already up there because we'd run it on Docker, but this time it is talking to my Kubernetes cluster. It's running on Kubernetes, and it is done with 3.5 minutes to go. So just very quickly recapping. With a bunch of audience help, thank you, appreciate it. A bunch of cool stuff from Docker, a bunch of cool stuff from Fermion, a bunch of cool stuff from the people at Containerd. We have taken a super simple piece of source code, compiled it as a WebAssembly binary, pushed it to, or we've containerized it in a way, we've made it into a container image, we've pushed it to Docker Hub, we've built and configured a Kubernetes cluster that will run Wasm apps, and we have actually ran a Wasm app. So that is the demo, and if it seemed hard this first time, go and watch it again on the replay later, or go to the GitHub repo, do it yourself. You'll really realize it is not hard. And 2.25 minutes, or 2 3/4 minutes, does anybody have a question? And if you do, please run to one of the mics and speak loud. I've got this guy in the middle, quick as you can, and then if we've got time after that, I'll come to you. Nice and loud in the mic, please.
Hello, how are you? Great demo. Can you hear me?
Thank you, I can.
Yes, so at first you said that the Containerd didn't know about, actually Kubernetes didn't know anything that runs below Containerd.
Sure.
But you still had to create the runtime class.
Yes, yes.
Why?
Yeah, so it's just, that was, the question was, why did we have to create the runtime class in Kubernetes if Kubernetes doesn't know about WebAssembly and what have you? It's basically just to help with scheduling and make sure that that WebAssembly workload gets scheduled to a node with a WebAssembly runtime. I feel like I haven't answered this question.
So if you don't want to schedule those containers in another node, you don't need to create the runtime class?
Yeah, so, okay, so if we wanted to scale on another node, we would have to just label another node.
But you have to label them to schedule them in those nodes. I mean, if you don't need to do that, if the Containerd is already configured in all the nodes?
Yes, so in my example, because Containerd has the Wasm shims on all 3 nodes, I would not have needed to do that, no, absolutely. One last question, 1 minute 20.
Okay, question is why?
Why?
To clarify on that, you have WebAssembly, you have Docker. Both of these are designed for portability and just trying to get at why are these synergistic as opposed to redundant ways of achieving.
So please come at 4:05 today, because we're going to talk about stuff like that in the panel. But I'm just going to challenge you on that. I love Docker and containers, but they are not designed to be portable. When you build a container, it is pinned to an OS and a CPU architecture. We call containers portable because they're small. They're easier to copy between a registry and a node than a VM. But that's not portability. So WebAssembly, as long as you have a runtime anywhere, you can run it anywhere. Whereas a container, yes, container build tools make it easy to build for multiple platforms now. But if you've got multiple architectures and OSs out there, you have to have multiple images, so you get a bit of image sprawl. honestly, everybody, thank you so much. We are nailed on time. Really appreciate it. And round of applause to yourselves. Thank you.